We're going to start with dispersion. A measure of location, such as the mean or the median, only describes the center of the data. It is valuable from that standpoint, but it does not tell us anything about the spread of the data. For example, if your nature guide told you that the river ahead averaged 3 feet in depth, would you want to wade across on foot without additional information? Is that enough information for you to use in deciding whether or not to cross the river? Probably not. You would want to know something about the variation in the depth. Is the maximum depth of the river 3 1/4 feet and the minimum 2 3/4 feet? If that is the case, you would probably agree to cross. What if you learned the river depth ranged from 1/2 foot to 5 1/2 feet? Your decision would probably be not to cross. Before making a decision about crossing the river, you want information on both the typical depth and the dispersion in the depth of the river. Here's another example. For an investor, the information on the average yield of a stock may not be sufficient. The investor may want to know about the stock's riskiness. The mean, which is the measure of central location, does not tell the investor about the stock's riskiness. Measures of dispersion do. Commonly used measures of dispersion are the range, mean deviation, variance, and standard deviation. So while the mean, median, and mode measure the central location of distribution, oftentimes we may wish to know the spread or dispersion of the data from the center. The range, mean deviation, variance, and standard deviation are the most commonly used measures of dispersion. The range is determined by getting the difference between the largest and smallest values of a data set. While it is simple to compute because it uses only 2 values in a data set, sometimes the range does not provide a true picture of dispersion, especially when a few outliers are present in the data set. A mean deviation is computed by adding the absolute difference of each observation from the mean and then dividing the sum by the number of observations. So to compute a mean deviation, the first step is to compute the arithmetic average of a sample. The mean is then subtracted from each of the observations in the sample. The differences, if negative, are converted to positive, are then added together. Once the absolute deviations are summed, the total is divided by the sample size to obtain the absolute mean difference. Other commonly used measures of dispersion are the standard deviation and the variance. For computing these measures, the mean is also needed. We'll start with an example on range. Consider the data on this slide representing the number of cappuccinos sold at the Starbucks location in the Orange County Airport between 4 and 7 p.m. for a sample of 5. The range of the number of cappuccinos sold is 60, obtained by subtracting the lowest value 20 from the largest value 80. As explained earlier, one of the shortcomings of the range as a measure of dispersion is that it is based only on 2 values, the lowest and the highest. It does not use all of the values. Another measure of dispersion, the mean deviation, does. It is computed by adding up the difference of each observation from the mean and then dividing the sum by the number of observations. So to compute a mean deviation, the first step is to compute the arithmetic average of a sample. A mean deviation is computed by adding the absolute difference of each observation from the mean and then dividing the sum by the number of observations. The mean is then subtracted from each of the observations in the sample, the difference converted to a positive, and then all are added. Once the absolute deviations are summed, the total is divided by the sample size to obtain the mean difference. Now we're going to go back to the cappuccino example we looked at to find the range, only this time we're going to find the mean deviation. The 5 observations are reflected on the slide. To compute the mean absolute deviation of the 5 observations, first we must compute the average number of cappuccinos sold. It is 50. We obtain this number by adding up all the 5 values and then dividing by the sum of 5. We subtract this mean from each of the 5 observations in the data set. This step is demonstrated on the next slide. After computing the mean, it is subtracted from each of the 5 observations. All resulting differences are reported in the absolute term, that is, as positive numbers. So the absolute differences are added. The sum, 80, is divided by the number of observations, 5, to obtain the mean absolute deviation of 16.